Today, we're going to talk about how to secure data through Kafka. Let's say your team has decided that integrating a stream processing platform into your systems is the best way to meet both the scaling and agility needs of your business. And Apache Kafka was the obvious choice as the platform to use. You've also decided to take advantage of the years of specialized experience in running Kafka at scale that you get from using Confluent Cloud, thereby allowing your team to focus on adding value rather than running infrastructure. The development is complete. The team has a working solution where producers can send data to Confluent Cloud and consumers are able to receive it on the other side. Communication between your producers and Confluent Cloud is encrypted in transit using transport layer security, and messages being sent from Confluent Cloud to your consumers are also encrypted in transit. Things are working great, and so you're about to proceed with moving everything into production. But a security and compliance review has surfaced a problem. While you trust Confluent Cloud, the increased focus on reducing supply chain risk means that having data move through their systems unencrypted no longer meets your organization's security requirements. And that's because while data is encrypted in transit, it's not encrypted for the entire time it's in motion through Kafka. Encryption and decryption is happening at the transport layer, meaning that your message is decrypted at wherever the edge termination occurs. That could be on the provisioned cluster, a load balancer, or a CDN, and those aren't implementation decisions you can control. But even if they were, the Kafka broker is still able to read the message in plaintext. So if the broker itself is ever compromised, then the plaintext data is at least temporarily available in memory whenever it is handling your messages. So how do you mitigate the risk to your business should some other vendor in your supply chain have a security breach? You need to be able to ensure two things. Number one, there is no possibility for a third party to read the data while it's in transit. And number two, that there's no possibility for a third party to modify the data while it's in transit. Without solutions to both of these, there is a risk that a security breach in your own supply chain can not only expose your sensitive data, but it can cause unexpected downstream escalations of their own. Ockam simplifies this by pushing cryptographic key generation out to the edges of the system, where authenticated encryption and decryption occurs. Producer and consumer are able to establish a mutually trusted, secure channel between each other. And by pushing the control of the keys to the edges of the system, no other parties in the supply chain are able to read or modify the data in transit. You can be assured that the data you receive at the consumer is exactly what was sent by your producers. Ockham's secure channels also regularly rotate authentication keys and session secrets. That means that if one of those session secrets was exposed, your total exposure window is limited to the small duration that secret was in use. With centralized shared key distribution approaches, there is the risk that all the current and historical data can no longer be trusted after a breach because it may have been tampered with or stolen. Ockham's approach eliminates the risk of compromised historical data and minimizes the risk to future data by automatically rotating keys. So that's a few unique benefits. 1. Unique cryptographic keys for every identity in your system. 2. Tamper-proof data in motion. And 3. A reduced exposure window if a session secret is compromised. And all of that is possible with no code changes and configuration updates that can be applied within minutes to existing deployments. Get started today with the Confluent add-on for Ockam Orchestrator.